All right. Well, I'll get started.
Really don't roll them over. Dude, really? You can't hit it. I thought you were on the football team. Because you hit it. I did not. Dude. Freaking liar. Well,
So, there is a test.
can we take the test today?
Take the test today. Well, that would be tricky because I don't have it written yet. But
All right, good. That means you make them up off the top of your head. Makes it more natural that way.
I usually make the test super long and then I edit it down. So if I just...
You can't make it where all
Hey, that quiz said it was today, didn't it?
No, tomorrow. No, it's Thursday. Bless you.
Yes. Thank you.
See, you never had a score.
I've shot hundreds of them. Squirrels.
Squirrel is a delicacy.
Dude,
Have you ever had raccoon?
right? Dude, no, but I've had possum.
Raccoon's good.
Disgusting.
Possum's disgusting?
Yes.
They're ugly.
Dude, because I remember one time my dad, it was when me and my brother were younger, he took us to the police office, so he took us out with like the police force because we were all doing like this big camping thing. Dude, one of the guys on this thing, we're all over by the campfire, we're here. This man comes back with a possum, sits there and skins it, gets over the fire and just starts eating.
Hmm.
I was like, what the heck? He was like, dude, you gotta learn to live off the land. I was like, he just squirrel over a possum. He was just sitting there eating possum.
All right. So,
I can shoot a deer so easily. But I always stay out there in my front pasture.
any questions about material and test?
What did y'all do last Thursday?
It's on the... I post a video.
Okay. I gotta look at that.
Did you vote today?
Nah.
Yeah, me
Did you get my email?
What's that?
Where I was?
neither. You didn't vote?
I mean, I voted like
You did?
a couple weeks ago.
Where are you from?
I mean, I was thinking about voting in Alabama since I already voted in Virginia, but, you know, well, I moved from Virginia.
You voted for Biden, right?
I voted in Virginia, so.
I don't know who that is.
I mean,
didn't see that on the ballot.
I voted in Virginia.
You should be.
There's still time to vote.
I can't. I gotta go all the way home, 3 hours away.
Oh.
There's no way I'm going all the way. I came too late for a reason. Dude, these Lamborghinis can move, but not that fast. These Lamborghinis, guys.
Lamborghinis.
Yeah.
It's an interesting saying. No, so last class, when there was me and one person,
Was it you?
Nah, it was you one. You was the only one in there last spot? No. Wait, are you talking about our class?
mm-hmm,
Was who?
mm-hmm,
Caleb?
yeah.
Yeah, I don't know.
Or mine just had to go.
When was that?
Hmm? That was last Thursday.
What was I doing last Thursday? I don't know. Oh, I'm not going to be here this Thursday.
I was trying to save my grade in one of my other classes
Uh-huh.
for hours because I did hours.
I was helping her.
Ah.
And I had to be at the dean.
You had to be at the dean?
I'm not.
Orthodont. He had orthodont.
Oh, the
I'm not gonna be
orthodontist.
here Thursday.
Did you really have
Thir-
to
We have a test Thursday. What's that?
Yeah.
You said quiz.
You said quiz.
Oh, quiz. I'm sorry.
Then you said you were going to cancel.
I'm thinking of the other class I'm giving a test, and it's fine.
But, well, you can give us a test today. Quiz today and test Thursday.
But, you know Dr. Kim?
I don't know Dr. Kim, no.
Well, I don't know him that good either, but he's on the 4th floor of laws. He
Mhm.
paid me to go to Arkansas with him Thursday.
Oh.
To help him move, and then he needs me to drive a U-Haul back.
Oh,
So you think
That's why I'm not going to be here.
I see. Very good.
that's not an excuse, is it? Failing.
Help a good professor.
Failing.
Whoa, whoa, whoa.
I should fail him.
Hey.
So, yes, if you'd like, you can watch the video from Thursday. Basically, we went back through the exercise sheet and did more of the same. So we've covered pretty much everything in the exercise sheets, right? If you guys have a question, you can ask. So with that, I think I'll go on to chapter 7. Which is on,
Is it rational expressions? Was that the exercise sheet?
yeah, rational expressions and what else? So chapter 7 is on quadratic equations and such. And so we've covered some of this already, right? But let me just take about a half hour to talk about it. And once I'm done with that, then if you guys still have questions about the stuff on the quiz, we'll come back to it, right? So what is a quadratic equation? So definition, if we have an equation of the form ax squared plus bx plus c equals to 0, this is a quadratic equation. Now, we're assuming here that a, b, c are real numbers, and a is not equal to 0. I mean, if a is equal to 0, then it would just be like bx plus c equals to 0. That's a linear equation, and we solve those a different way, right? But if it's a quadratic equation, we can ask, well, how do we solve this, right? And we already know, right? So how do you solve this? Well, we already know that we can look at b squared minus 4ac, right? And this is called the discriminant. And basically what happens is there are 3 cases, right? If b squared minus 4ac is greater than 0, that says 2 solutions, 2 real solutions. If, on the other hand, case 1, if on the other hand b squared minus 4ac is equal to 0, that implies repeated real solution. Right? And finally, case 3, if b squared minus 4ac is less than 0, that implies a complex solution. Right? Now, so you can anticipate what's going to happen by calculating the discriminant, right? And so we have different ways we could approach solving this equation. We could use the quadratic formula as one way, right? Or we could complete the square. I'm going to advocate completing the square because it will solve another problem for us as well. Get up here. Okay, so let me look at some examples. So example 1, if we had, say, 2x, well, let me keep it simple, x squared plus 6x plus 5 equals to 0, right? Let's calculate the discriminant. I mean, to solve it, we do what? X plus 1 times x plus 5 equal to 0, which tells us x equals to minus 1 or minus 5, right? There you go. That's the solution. So that's, of course, the easiest possible, well, one of the easiest ways it can happen is if we can just factor the quadratic, then solving it as simple as this, right? But sometimes it's not obvious how to factor it, right? let's check the discriminant here, by the way. By the way, b squared minus 4ac, what's that equal to here? 36. Let me write it out. 6 squared minus 4 times 1 times 5. That's 36 minus 20, which is 16, which is greater than 0. So as you can see, my example 1 really does fit into case 1, right?
So, I'm confused as to what we're trying to get to. Are we trying to get to the x equals -1 or -5, or?
At the moment, I'm just solving the quadratic equation. I'm reviewing how to solve the quadratic equation. There are I would say three major methods. The one is factoring, right? The other would be completing the square. And then I'd say the third is, just using the quadratic formula. All right. So I don't want to advocate like always completing the square, because goodness gracious, when you can factor and it's easy to factor, then just do it, right? Like this one's, another one's going to be like that, x squared minus 6x plus 9 equal to 0, right? So this one we can just factor again, right? This is x minus 3 times x minus 3 equals to 0, right? And in this case, you've got, okay, so x equals to 3 twofold time. I mean, x equals to 3 twice is the double solution, right? Repeated real solution. And so there. Now, let's look at example 3. Suppose we had, I should check I'm trying to illustrate the discriminant, right? So by the way, b squared minus 4ac, what's it equal to here? It's equal to minus 6 squared, right? Minus 4 times 1 times 9. Otherwise known as 36 minus 36. What's 36 minus 36?
0.
Yeah, 36 minus 36 is 0.
That'd be equal.
Right. So as we
So
found,
you're just proving that it works out.
yeah, I'm just illustrating that the discriminant really does tell you what kind of solution you're in, right? That's what I'm at the moment doing. 3, if we had x squared plus 4x plus, 7 equals to 0. This we won't be able to factor this nicely, right?
Sorry, I'm late.
You're okay. So,
I forgot to tell you, I was supposed to tell you.
Oh my, you didn't tell him?
My bad. Dude, I totally forgot.
I know I should have texted him.
You texted me?
No, I said I knew I should have.
Dude, I'm sorry. Hayden was distracting me from walking.
so 16 minus 28 is minus 18, which is less than 0. So the discriminant being less than 0 tells us that, in fact, we're in the case that there's a complex solution, right? Now, in this case, we can use completing the square as a way to solve this. Let me show you how. So we have x squared plus 4x plus 7 equals to, well, x plus 2 squared minus 4, right, plus 7. In other words, x plus 2 squared plus 3. Now, so it doesn't factor, right? It doesn't factor nicely. Now, if I want to say that this is equal to 0, how can I solve it then? How can I solve this if this is the deal? How about this? We could look at this as x plus 2 squared equals to minus 3, right? And then if I take the square root of the equation, right, I have to allow for plus or minus on both sides, right? So this tells me x plus 2 is, yeah, plus or minus the square root of minus 3. Almost. Yeah, bring the 2 over. X equals minus 2 plus or minus, well, and by the way, plus or minus the square root of 3 is plus or minus the square root of minus 1 times 3, right, which is plus or minus the square root of minus 1 times the square root of 3, which is plus or minus I times the square root of 3. Oh, this is not for the quiz. This is for after test 3.
What do you want us to put the I?
This is for final exam part 2. I could put it on part 1. What? No.
But if you feel it pretty, go ahead.
When's the quiz?
When? Thursday, yeah. So plus or minus I root 3.
And there you have it.
Right. And as you can see, this is a complex solution, right?
Correct.
Now, the other way you could do this, if you don't, I mean, this is one way. You can solve for the square, take the square root of the equation, get plus or minus the square. I mean, that's one way to do it. Alternatively, we could have noticed that x plus 2 squared plus 3 is x plus 2 squared minus 3 minus I times the square root of 3 squared. See, because I squared is minus 1 and the square root of 3 squared is 3, so I can rewrite 3 as minus parentheses I root 3 squared. And then I've got the difference of squares, so I can use the, usual x plus 2 minus I root 3 times x plus 2 plus I root 3 factorization. And then once you see that factoring, right, so in the case that the discriminant's negative, the polynomial factors, but only over the complex numbers, there's a complex factoring. And of course, the zeros corresponding to these factors are exactly the ones we found by using our previous argument. So like, you got a choice. If you're solving the equation, you could like do this factoring that I just did to see the solution that way, or you can take the square root and put plus or minus. It's up to you, right? If the question is just to solve. If I ask you to factor the quadratic over the complex numbers, then you need to understand the thing I just wrote at the bottom, right? So. Now, oh man, that's a mess. Let's look at some examples where the leading coefficient is not 1. So what if we have like 2x squared plus 7x minus 2? All right. So I just made this up. It's probably not nice like the ones we've done. So what we're going to have to do is we're going to have to factor the 2 out. All right. So that's my first move, is I factor the 2 out. Once I've done that, then I can complete the square like we've already been doing. So I've taught you how to complete the square as long as the leading coefficient's 1, right? If the leading coefficient's not 1, you just factor it out. And then you can go back to how to do it with 1. So I just ignore this 2. It stays out there. And this is x plus 7 over 4 squared. minus 7/4 squared minus 1. But instead of writing 1, I'm going to write 16 over 16 because I see where this is going. See that 1 is 16 over 16. See, because if I do that, then I can recognize 7 squared over 4. 7 over 4 squared is 49 over 16. So then I've got like a 49 and a 16. 49 plus 16 is 65. So I got 65 over 16. What did I say, 65?
Yes, sir.
All right, so after you've completed the square, then what has been revealed is whether or not you can factor, all right? After you complete the square, either you're going to get something squared, like x plus something squared minus something, or x plus something, plus or minus something squared plus something. If it's minus, it means you can factor it over the reals. If it's plus, it means it factors only over the complex numbers. But we can always take this and like rewrite it as a squared thing. So this, if you want to rewrite this as something squared, you just say, well, it's the square root of that squared. It's kind of stupid, but there it is. And so that's 2 times parentheses x plus 7 over 4 minus the square root of 65 over 4 x plus 7 over 4 plus the square root of 65 over 4. And so if I look at 2x squared plus 7x minus 2 equals to 0, I can see from right above that the solution is what? It's x equals to minus 7 plus or minus the square root of 65 over 4. Why is there this, what's this, I don't talk much about it, but if you were an advocate for the quadratic formula, that's what you're looking at right now. This is exactly minus b plus or minus the square root of b squared minus 4ac divided by 2a, where in this case a is equal to 2, b is equal to 7, and c is equal to minus 2. So if our leading coefficient is not 1, we can still do it. We just need to factor it out, all right? Oh, this is a worthless, oh man, I don't think did I hit record? Did I hit record? That's a decent question. I did hit record. Good news, I hit record. However, the bad news is I had not panned over. So my apologies to people who aren't here. Let's see here. Let me give you an example 5 here. I don't do well with multitasking.
Would it not be easier just to do the minus b plus or minus square root of b squared minus 4ac over 2a?
Yes. Yes and no.
Looks a lot easier than that.
It depends. Let's see here. 3x squared plus 12x plus, let's say, 10. All right. So I'll pull a 3 out. I've got x squared plus 4x plus, well, 10/3, right? Now I can complete the square. 3x plus 2 squared And then I have to, of course, subtract 4. And I've still got the 10/3 there. Did I say plus 10? I meant plus 20, guys. I'm sorry. Make this 10 a 20. My apologies. 20. 20. So how many thirds is 4? 4 is what? 4 is 12 thirds, right? So this is minus 12 thirds. So how many thirds do we have then? Eight thirds, right? Any questions so far? So can we factor this one over the reals? Nope. We got a plus after completing the square, right? That means that the solution is actually going to be complex, right? So if that's equal to 0, what's that say? That says that x plus 2 squared, right, is equal to minus 8 thirds. And so x plus 2 is equal to plus or minus I times the square root of 8 over 3. So this is like a go-to formula. If I have the square root of a real number with a minus in front of it, I can just rewrite that as I times the square root of a. So like this is just a nice thing to know about. If we want to pull a minus out of a square root, we can pull an I out. All right, just like that. And so the solution here is x is equal to minus 2 plus or minus I square root of 8 over 3. What's the discriminant for this? What's that? You guys, what you got? You didn't get that?
Well,
You use the quadratic formula?
hang on a second. I got it. I didn't work it out.
Oh, it's okay. But you know, complex. So the complex solution always comes in a conjugate pair as well, right? Like it's always plus I minus I. You know, you can't have like a quadratic equation where one of the solutions is real and the other one is complex, right? The complex solutions always come in this pair. One's got the plus I, one's got the minus I. Like it's always like that. Okay, so to answer your question, you're asking me like, well, why don't we just use the quadratic formula? Like, what's the point of completing the square? How is it helpful? Well, let me talk about that because it has to do in part with graphing. Right, so if we want to graph y is equal to ax squared plus bx plus c, it is super useful to have that rewritten in a certain form. All right, so we can rewrite this in what's called vertex form. And what that looks like, and people typically use h comma k for the vertex. So basically the parabola will look like maybe this is the vertex, right? And then parabola opens up from the vertex symmetrically. So this is the lowest point if this is for a positive, right? What would it look like if a is negative? Like that, right? And the zenith, the high point, is h comma k. I can tell you some other things about the graph, right? So, chapter 7 is about mastering quadratic functions and quadratic equations, like trying to understand them as best we can. So like point number 1 on our bucket list is just solving the quadratic equation. We can do that. We can either factor, we can complete the square, we can use quadratic formula. We got that covered, right? Next up is graphing parabolas, right? How do you graph y equals ax squared plus bx plus c for like arbitrary choices of a, b, and c? Well, if you can factor it, that tells you x-intercepts, right? That's great. It may or may not have those, right? Like both of the ones I have, both of the ones I have pictured at the moment have discriminant what? Can you tell me? I'm assuming that was for Jason, so
It was.
I'll allow it. Let's see here. So you could say this. Just.
I told you he did that last week and nobody believed me.
Oh, really?
Yeah.
I did not.
Oh. But you didn't. But you said you didn't vote for anybody.
I didn't go.
Hmm.
3 hours away.
Now, some people say that because you didn't vote today, that means that you're not allowed to complain about like the structure of U.S. government for the next 4 years. I reject this. I say anyone who pays taxes should be allowed to complain. That just makes sense to me. I mean, if they're going to take your money, do you pay tax? Did you buy gas? Do you go to stores? It's here. No.
I was about to say.
I was meaning like middle.
How's that? All right.
He's not a landowner. Let's see here now.
Oh man.
So
Just went from yellow to orange. What? I don't know. I just got an email saying Gilbert's from yellow to orange.
I don't know what's happening here.
What is that?
I don't know. You go read it.
So these R minus and R plus. If I could factor this, right, into A times x minus R minus times x minus R plus, like in the pictures below, this assumes what? B squared minus 4ac is greater than or equal to 0. If it was equal to 0, well, that would mean that R minus and R plus are equal. It would be repeated root, right? So I guess I should probably say, for the sake of the two pictures which are given here, the discriminant's positive, right? It looks either like this or like that. Can you tell me anything else about the pictures? Can we add, how does it relate to the given formula? Ax squared plus bx plus c. There's something else we could say concretely. How does c relate to the picture? What is c equal? What is c as it relates to the graph? If we think of this, I mean, I should really think of this as f of x. Think of it as the quadratic function. So a quadratic function is a function whose formula is given by a quadratic polynomial like this one. So remember the y-intercept we get by taking the function and evaluating at 0, right? F of 0 should be the y-intercept. So f of 0 here is just c, right? C is the y-intercept. So this is c, and this one over here is c for my pictures. What's the formula for R minus and R plus? Do you know? Minus b. Let me say R plus minus. Plus or minus the square root of b squared minus 4ac divided by 2a, right? That's the formula for the roots. If you wanted the formula, the quadratic formula gives you the places where the x-intercepts are. Those are the places where f of x is equal to 0, right? If there is such a place. There doesn't have to be in general, right? Because what's the other thing that could happen graphically? put it down here. But you could have something that looks like this, right? You could have a parabola that looks like that. Or it opens down and it never crosses the x-axis, right? In this kind of case, you can still talk about the vertex, but you can't talk about the x-intercepts, although the y-intercept is still c, right? So I still haven't really come back to answer your question, why does completing the square help us graph, right? But let's talk about it. So the vertex formula for the quadratic, which I still haven't stated, because I'm trying to find a good spot to put it, I guess I'll put it here, is y is equal to a times x minus h squared plus k. So if you complete the square, it's pretty easy to get to the vertex form of the parabola, right? So if you can see what the vertex of the parabola is if you can write the formula like this. Let me circle back to our two previous examples. Like for example 5 then. Where's the vertex in example 5? See, we got to this right here, right? So notice that we could have written y, if we look at y equals to 3x squared plus 12x plus 20, we could rewrite that as y is equal to 3 times x plus 2 squared. See what happens here? When I take this and I multiply 3 through, what do I get back? I get 3 times x plus 2 squared, and 3 times 8 over 3 is just 8 again, right? So if you look at this, then you can say what the vertex is, right? What is the vertex of the parabola? Nobody? Compare this formula to that general form. The vertex is h comma k. What is h and k?
Oh, 2 and 8.
2 and 8. Almost correct. Can somebody fix it?
Good guess, Hayden.
How's that almost correct?
It's x minus h. It's just like that persistent issue of, yes, but it has to be minus, so we have to look at,
-2.
there you go.
Good job.
I appreciate that.
You guys got to stop knowledge shaming Hayden. It's not nice.
I wish I just had a piece of his knowledge so I could
No,
make
you don't want what goes on up here.
Okay, so roughly speaking, the vertex is about right there. And the vertex, so guys, the vertex goes through what's called the axis of symmetry for the parabola, right? If you were to draw a vertical line, through the vertex, that's the so-called axis of symmetry. What's going to happen is the parabola is just mirroring itself over that line. So once I know where the vertex is, and once I have a couple more points, then I can pretty much graph the parabola carefully. What's the y-intercept for this?
Yes, sir.
3x squared plus 12x plus 20. What's the y-intercept? What's that?
Yes, sir.
Yes, sir. I'm missing something. No village peopling. No village peopling in my class. I said no village peopling. That's right. Is that villaging? What is the verb of village peopling? I don't know. the y-intercept, because there's a 20 here, is 20, all right? So it's like up here somewhere. And so roughly speaking, the parabola would look something along the lines of this. So if we can complete the square, we can easily see where the vertex is, and we can also solve it. Like in all possible, like completing the square is very close to solving the quadratic equation.
I just want to know who had the knowledge to sit down and come up, because you know they did not know anything that they were doing. It's like, if I draw a line like this, it's going to make this equal this.
Basically, we're learning nonsense.
Who understood how to complete the square first? Is that you're asking? I don't know. That's a good, I mean,
I think Jason should have
I found the guy.
Google it and then write a paper about it.
I got a guy that found the square root.
you got a guy?
Yeah.
He knows a guy?
I know a guy that found the square root. Wow.
I'm not looking, I don't know what that is, but I'm not.
No, look at it. It's nothing bad.
Yeah.
Boy, found the square root. What do you mean?
The square root, yes. It's kind of more of a quadrilateral, I think, but square. It's pretty square.
What is it, just a picture of a
It's a
square root?
it's a picture of a tree with a square root, yeah. Essentially. So, okay. So that was the graph, roughly speaking, corresponding to the quadratic in example 5, right? What would the graph look like for this one? If we wanted to look at y equals to 2x squared plus 7x minus 2, where's the vertex?
-7, -2. Or it'd be +2. This is positive on that one.
Well, we need to,
It's -7 something.
so let's see here. Let me write it out again. So this is, what? Wrong side. So this was 2 times x plus 7 over 4, right? And minus 65 over 16. But that's all times 2, right? So one more step. This is 2 times x plus 7 over 4 squared minus 65 over 8. So from that, I can tell you the vertex is where?
-7 over 4, comma. Would it be positive or negative 65 over 8?
Negative 65 over 8, yeah.
Well, how come we have to change that one to -7 over 4?
Because
the last one stays the same.
it's because y and x are different when we're thinking about the graph y equals f of x. I mean, there's an asymmetry there, right? Functions have to pass the vertical line test, but they don't have to pass the horizontal line test. But the role of x and y is different, right? Like x is squared versus, it's not. So sometimes I think it's helpful to like convert to decimals just to see it. Like in decimals, what is this? 7/4, that's 1.75, right? So minus 1.75. And 65 over 8, well, that's, trying to think here, 8 times, what's that? 8 plus,
8.125.
all right, so minus 8.125. So there you go. There's the decimal, location, if you will, of the vertex. And so, roughly speaking, around here somewhere. There's the vertex. What's the y-intercept?
Y-intercept.
Mm-hmm. So the is -2, right? So it's about right there. And so this is the axis of symmetry for the thing, right? And so it's got to be. I mean, technically I should find like another point or two.
That one was good.
Where are these points that it crosses the x-axis? What are those values? Like this right here is what? This would be -7 plus the square root of 65 divided by 4. What's that equal to as a decimal? So what's -7 plus the square root of 65 all divided by 4? What you got? Did you get it, Kayla? .266. All right. So that's it's kind of probably a little bit closer to the y-axis than I have it pictured, maybe a little bit, but up to the limit of the precision of my graphing here. And this one over here should be -7 minus the square root of 65 over 4. What's that equal to? Minus 3.77. So I think that pretty well checks with we have, right? So what I'm trying to share with you is for a quadratic, we can make a very good picture of it by taking time to appreciate how the different aspects of solving the quadratic formula relate to graphing it, right? Completing the square, we can find the vertex, not directly, but pretty close to it, right? If the leading coefficient is 1, then you can just read the vertex off completing the square, right? Like when the coefficient's not 1, it makes it a little bit more complicated, and I wanted to show you that, but let me just do a couple easier ones. I hope I haven't erased something that I haven't videoed. Oh. I was like, oh, okay. So example 6, is it? If we have, y equals to x squared plus, 16x plus, say, 30. We can complete the square. And see, if the leading coefficient is 1, then you can just straight read from completing the square what the vertex is. Where's the vertex? -4, right?
Plus 14.
Plus 14.
That's simple.
Right. And so you can graph that thing. -4, 14 here somewhere, right?
And 30.
Thank you. 30 is about
Up yonder.
up yonder. Sure, why not?
You forgot the other little line thing that goes on the outside of the number.
Yeah, I did. The other little line thing, yeah, that. Yeah.
It's a parenthesis.
A parenthesis, yes.
Parenthesis.
This is a
You gotta draw your little horseshoe.
this is a silly place. Let's see here. So there you go.
That's the horseshoe.
So roughly speaking, there you go. That's the graph of the parabola, right? And there's no.
I got a question, Mr. Cook.
Sure.
Why do we need to know this? Like, this is even like.
Because he said so.
You're asking for what is a real world application.
Like, why?
Well, he's a math teacher, so he needs it.
You're asking.
Yeah,
Besides if you're.
why do we need this? We just need, all we need is multiplication, adding, subtraction, and division.
Is your question what's the real world application?
Yeah, like, why?
Well, if you think
Well,
about it, you do add, subtract, multiply, and divide and all of that.
Yeah, but you don't need like the whole alphabet. You know, what is
Well, my first response to that question is usually to ask you, do you deny your own existence?
Wait, what?
Do you deny your own existence?
Sometimes.
Well, yeah.
See, because I feel like students are in the real world, and I feel like students taking my tests, that is an actual real world application of the math. See, you're not, that's not real world? Oh, after college.
After college.
This class doesn't get college credit. I think my point still stands.
After we leave you, after we don't.
After you leave. Quadratic,
I think we all think.
so, I mean,
It's been a long day, we need to go home.
joking aside, quadratic formulas come up in all kinds of applications, like, most notably probably just gravity, right, like that. So that's
What
a
goes
quadratic
up,
formula.
down, that's simple physics.
So like y is equal to y naught plus v naught t minus 1/2 gt squared. So this right here is the equation of vertical motion under gravity. So like the initial velocity is y naught, the initial position is y naught, and that's 9.8 meters per second squared, And so, like, if you wanted to complete the square on this, then it would tell you something about, what would it tell you? I mean,
There is something, isn't that the fall of gravity, 9.8 meters per second?
mm-hmm,
Ain't that gravity?
yeah.
So,
So that's one, in one sense in which there's parabolic motion. In like the sense of y versus time, but there's also parabolic motion, like if I was to say, like, take this piece of chalk and throw it like this. Yeah, so like that. So, like this. It's parabolic motion. Now that's not as obvious, but well, here I'll show you. Yeah, you got me. So this is actually v naught x, y rather. And so like x is equal to x naught plus v naught xt. So these are the so-called parametric equations for like just ignoring friction and motion under gravity. You've got a linear equation, you've got a quadratic equation. You can eliminate time. So like solve this for time. This gives us time equals to x minus x naught over v naught x. So like the velocity is generally a vector. It's got two components, the x part and the y part. So that's the v naught x and the v naught y. It's the x part of the velocity and the y part of the velocity. And if you've just got a y part, it just goes up and down. If you've got an x part, it's like this.
still hit me again.
He didn't even look.
So I actually wear glasses. That's dangerous. So if you plug that in to here, you have what? You got y equals to y naught plus v naught y times x minus x naught over v naught x minus 1/2 g x minus x naught over v naught x.
I wasn't throwing it.
Scary though. And I don't want to pursue it fully, but that's a quadratic. That's a parabola, right?
Yes, sir.
Well, I learned more today about physics than I have math the whole semester.
So
You're a
That
good
is,
teacher.
that is a good point.
I don't know what that means, but so this is a parabola because it has if you expanded it all out, it's ugly, but you'd have ax squared plus bx plus c, right? And so if you just have motion without ignoring friction under constant acceleration of gravity, that actually gives you parabolic motion. I mean, hypothetically, if you could take experiments on some other planet and track the motion of a ball, you could like reverse figure from that. You could cipher from that what the gravity was on that planet, among others. I mean, you could do kind of stuff like this, but that's one place. The other place the quadratic comes up that's pretty natural is Hooke's law. So like the motion of a spring comes up there. Oh, so still like you guys take packing up early to another level. Like we still have like 12 minutes till the end of class, but you're like already packing up. It's like
No, actually, we're like 45 minutes past because see, your watch is wrong from time change. It's really 4 o'clock.
Bang!
Got him. I need your help after class and your help.
My help before.
Just to figure out.
I don't even know what to do, you guys. I have another example.
I gotta go to limit.
What do you need help with?
What homework?
No, not like
Do you
help
have
to
to
do
get
it.
to it?
So like get to it. Like I can get to it, but when I click on it, it doesn't pop up. Like it's just blank.
Well,
But
see, what I'm gonna do,
her
I'm gonna do all
friend
mine on
It's trying to get me on the show.
Her friend figured
Dude,
out.
no, I applied for a thing, and they just sent me 3 different texts saying, hey, we want to do a
He was
Zoom
talking.
meeting with you about the thing. Which time is that? 11 a.m., 2 p.m., or 5 p.m.?
6 p.m.
One out of the bank.
so your first line of defense, graphing a quadratic though, is just plain old factoring, right? If you can just factor it, then you can find the x-intercepts and graph it that way as well, right?
Correct.
What's the relation? What is the relation of the vertex and the x-intercepts? Is there any relation? Can you tell me how they're related? Let's see here. How about this one? This is x minus 5 times x minus 1, right? But on the other hand, it's also x minus 3 squared minus 9 plus 5, also known as x minus 3 squared minus 4. So we've got vertex at well, not minus, but 3 comma minus 4. And we have x-intercepts where? At, well, 5 comma 0 and 1 comma 0. So, oh, I've better graph it over here. So 1, 0, 5, 0, and 3 comma minus 4, like that. What's the y-intercept? Is what? What's the y-intercept here?
Oh,
-4.
5.
5.
Y-intercept is the constant. And so there you go.
That almost makes a right angle. Never mind, never mind. To the point of the bottom.
So,
That's an acute angle.
so my question to you is, how is the vertex related